Hello all, I'll be giving you hints as I promised for your project. Well, starting without further ado, let's consider this IPv4 header. It has 4 bits for the version field, 4 bits for the IHL field, and so on. What you must not forget is that when a packet leaves your computer into the wire, it's always in binary form. And you can take advantage of that by crafting your packets in a binary form. And since binary form of numbers is found in hexadecimal digits as well, which can be initialized in your C program, you need not worry at all. Take the example. You have the version field. Its size is 4 bits. But the default value we know in IPv4 is the decimal digit 4 or the hexadecimal digit 0x4. In a similar manner, you can always initialize values of your IP header to be something by default. To give you an example, if you use Wireshark or have seen Wireshark streams of packets, you will see that the packet contents look like this. On the left you see hexadecimal digits, and on the right you see the equivalent ASCII format. You can see that there's an invite packet being sent via the session initiation protocol from Mohit to Chirag. But on the wire, it's undetectable. You can't say that, oh, hexadecimal character 3A is perhaps the uppercase I. You cannot say that. It's in transit, you can't make out. So you have the power now to craft packets in hex and send them. That's one option. But beware, IP addresses do not convert themselves, because if you type 13.0.0.5, that is in a string format. That needs to be converted to an equivalent hexadecimal format. As you can see, it is 32 bits. So the integer field holding this IP address's hexadecimal value must be of the same size as that of the IP address itself. To give you an example, IPv4 address rather, is 32 bits in size. So you need to have an integer, which of course will be int in this case, to be 32 bits on that machine. It cannot be 16, it definitely cannot be 64. So all we need to do in the first approach is define an array or list containing these hex values, and we have to write them. But the question comes, where do we write them? Well, if you remember, Unix treats everything as a file, even socket descriptors. So all you need to do is arrange all this hexadecimal data based on your layer, and you need to send it by issuing a write function call to your socket descriptor, and that is it. Unix keeps things simple. If you do not believe me, try troubleshooting problems on Windows. The first approach can be said to be a bit harder. It's not that hard, but it's a bit cumbersome if you ask me. The easier of the two approaches is that Unix itself contains structures which contain headers for TCP, ICMP, UDP, IPv4. Well, I think I've spoken too much, but yes, it is the truth. You can automatically populate these fields in a structure and send them using the send function call or the write function call, as I previously mentioned. So this is another approach you can use. Well, I'm not going to give you the details about where these structures are located. That of course holds true unless you ask me. So I look forward to questions from you in this topic especially. Some tips before you start programming. It's recommended that you install a C++ IDE like Genie to develop code, because features like auto completion will help you. Of course, the GCC usage is same as the one I had mentioned in the sockets program class, where we discussed and demonstrated the simple program which requests a file from a server. Oh, speaking of that little program we developed that day, here's your homework. Step 1, install Wireshark on any of your virtual machines. Step 2, start analyzing any packets which go in and out of your virtual machine. Step 3, install the server and the client programs which were taught to you that day. I think I have sent them to you in Step 4, run that program on your virtual machine while Wireshark is running or capturing packets. And the last step, you need to tell me with a screenshot what kind of headers and what kind of content do you see there. This will be your homework. Once you do this, you will understand thoroughly how networking really works. If you have any doubts, please let me know. I'll be on call anytime you want me to. And thank you so much for watching.